Hi, my name is Ciera Hudson, and this is my video for the Physics Lab 2. In this experiment, we were asked to determine how much excess charge is on one piece of clear tape. In the first lab, we did this using a glow script model with point charges, but this time we'll be modeling the forces as rods, so we'll be able to integrate the forces and determine a more accurate estimation of how much excess charge is on one piece of clear tape. We will also be answering some reflection questions to further our knowledge of the subject. The first step in the experiment was to create a charged piece of tape by sticking it onto another piece of tape on the table and then pulling it off very quickly. This caused a transfer of electrons. We were then able to determine if the charge on the piece of tape was positive or negative by rubbing it against a plastic pen. We knew that this plastic pen was negatively charged and that the tape was repulsed by it, so we knew that the piece of tape was also negatively charged. The second part of the experiment was to create two pieces of tape that were charged and then analyze the interaction between them. The first piece of tape would be suspended horizontally between two vertical objects with a little bit of slack in between. We would then create another charged piece of tape and hold it underneath the first tape, moving it slowly upwards. When the upper piece of tape began to float, we would record the distance between them. In this lab, several assumptions were made. The first one was that each U-tape would have the same net charge, and the second one was that each tape will be treated as if the charge is constant from one end to the other. This is different than in the previous lab, where the whole charge was treated as one point charge. The initial values that were used were the distance between the pieces of tape, which was 0.015 meters, the length of one piece of tape, which is 0.2286 meters, and both pieces were the same, and the mass of one piece of tape, which was 0.2286 grams. There were several relevant equations and constants that were used in this lab. Newton's first law states that an object at rest will remain at rest unless it is acted upon by an unbalanced force. The unbalanced force in this equation is the electric field, which exceeds the gravitational force, pushing it downward. Newton's third law states that every action has an equal and opposite reaction, showing that the electric forces of the tapes balance each other out and act in opposite directions. Coulomb's law states that the force of the electric field is equal to K times Q1 times Q2 over R squared. This is used to find the electric force. Fg equals mg was used to find the gravitational force, and F equals QE was used to find the electric force after knowing the electric field. The relevant constants included gravitational acceleration, which is g equals 9.81 meters per second squared, Coulomb's constant, which is 9 times 10 to the 9th, and the charge on one electron, which is negative 1.6 times 10 to the negative 19th coulombs. This is the glow script code that was used to create the computational model. Several changes were made from the starter code, which included the net charge from Lab 1, Q equals 7.4876 times e to the negative 9th, the vertical distance from one tape to the other, which was 0.015 meters in the y direction, and the equation for the electric field created by one point. Additionally, changes were made to calculate the electric force on a portion of the top tape by a portion of the bottom tape, and to calculate the arrows in terms of direction and magnitude of the forces acting on the top tape. Here are the results from the glow script model. As you can see, there are green electric field arrows pointing in mostly the y direction, but have x components. This shows all of the forces that were acting from the bottom tape on the top tape in a linear direction. The electric force arrow is represented by the white arrow in the positive y direction, which is balanced out perfectly by the gravitational force arrow that is acting in the negative y direction. The magnitude of the electric force was 2.24257 e to the negative 3 newtons, which was equal to the magnitude of the gravitational force. We were able to determine that the charge on the tape was negative, which means that it had an excess of electrons, and that the charge on each piece of tape was equal to 3.2526 e to the negative 9th coulombs. If we had modeled each of the tapes as a single point charge, it would have yielded a different result for the charge on one single piece of tape. As you can see, there was a large difference between last lab and this lab in terms of the charge on each piece of tape. These estimates differed because the current model is actually closer to the real value. Because the pieces of tape are holding the charge along a line, this lab's model includes interactions between each section of the tape and creates a more precise version of the charge. Thanks for listening.